Hello everyone! Welcome to our General Mathematics class. For today, we will have the Introduction to Functions writing a function rule. In many situations, data is collected by conducting a survey or an experiment. To visualize the data, it is arranged in a table or a graph. Most often, a function rule is needed to predict additional values of the independent variable. To understand this one better, let's have an example. In here, we will see the number of CDs 2, 4, 6, 8, 10 and the cost 24, 48, 72, 96 and 120. Notice that the values under the cost is dependent on the number of CDs. The more CDs you'll buy, the bigger money it will cost you. Thus, the number of CDs is our independent variable x while the cost is our y. Going back to our table and inspecting each values, you'll pay 24 pesos for 2 CDs, 48 pesos for 4 CDs until 120 pesos for 10 CDs. So how much will 1 CD cost? You're right, it's 12 pesos each. Writing that into a function rule, we'll have y is equals to 12x or f of x is equals to 12x. Because again, the cost, which is y, depends on the number of CDs, which is x, and each CD costs 12 pesos. Let us consider another example. As you can see, all the values of x and y are almost the same except for the signs. And the values of y are all positive. This is a special relationship named as absolute value. So our function rule would be y is equals to the absolute value of x or f of x is equals to the absolute value of x. Let's now proceed to problem 3. A taxi ride costs 40 pesos plus 15 pesos per kilometer driven. Write a function rule about the cost of a ride. In here, the cost of a ride is our y since it is dependent on our x, which is the number of kilometers driven. Therefore, our rule here is y is equals to 40 plus 15x or f of x is equals to 40 plus 15x. This is because a passenger will pay 40 pesos even if the ride has not yet started plus 15 pesos per kilometer. Let's now have problem 4. When diving in the ocean, you must consider how much pressure you will experience from diving a certain depth. From the atmosphere, we will experience 14.7 pounds per square inches, and for every foot we dive down into the ocean, we experience another 0.44 psi in pressure. Before we get the function rule or equation here, let us first understand the pressure we experience in the ocean. At sea level, the air that surrounds us presses down on our bodies. You don't feel it because the fluids in your body are pushing outward with the same force. But dive down into the ocean even a few feet though, a noticeable change occurs. You can feel an increase in pressure on your eardrums. This is due to an increase in hydrostatic pressure. The deeper you go under the ocean, the greater the pressure of the water pushing down on you. That would easily snap our bones. Now going back to our given, the pressure that we will experience depends on the depth that we will going to dive. Therefore, our rule would be y equals 14.7 plus 0.44x or f of x is equals to 14.7 plus 0.44x. Remember that the pressure is equals to 14.7 psi when simply staying in the ocean, plus 0.44 psi for every foot we will dive down. Now, how far can you dive without experiencing more than 58.7 psi of pressure on your body? To answer this, we will be using the function rule. Y equals 14.7 plus 0.44x. 58.7 is the value of y because it's a pressure on your body, So we'll simply substitute this one to our y. To isolate x on one side, we have to subtract 14.7 on both sides. Operating the left side, 58.7 minus 14.7 is equals to 44. Divide both sides by 0.44 to get x. Therefore, our final answer is 100. With this, we can say that for a diver not to experience more than 58.7 psi of pressure on his or her body, he or she should not dive more than 100 feet. That is all for today. Thank you and see you on our next video lesson. Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! For today, we will discuss about identifying a function. Before we begin, let us first define relation and function. A relation is a rule that relates values from a set of values, called the domain, to a second set of values, called the range. A relation is a set of ordered pairs x, y. A function is a set of ordered pairs x, y such that no two ordered pairs have the same x value but different y values. Using functional notation, we can write f of x is equals to y. In particular, if 1, 2 is an ordered pair associated with a function f, then we can say that the function of 1 is equals to 2. Looking at the definition, both are a set of ordered pairs x, y. Therefore, we can say that a function is a special type of relation. All functions are relations, but not all relations are functions. Relations can be represented by ordered pairs, table of values, mapping, and graphs. Let us start with ordered pairs. Which of the following relations are functions? Before we begin, always remember that for a relation to be a function, all values of x must be unique or non-repeating. Also, for every x value, it should only be paired with only one y value. So let's start. We have here a relation f with ordered pairs 1, 3, 4, 1, 2, 0, 7, 2. Inspecting the domain or the x values, we have 1, 4, 2, and 7. All are unique and non-repeating, therefore this relation is a function. Next, let's have relation G. Looking at the x values, we have 3, 4, 3, 8. 3 was repeated twice under the ordered pair 3, 2 and 3, 3. Therefore, this relation is not a function. Now let's have relation H. Again, look at the x values or the domain. We have 1, 2, 3, 4. These are all unique, therefore this relation is a function. We have here another relation I with ordered pairs 0, 1, 1, 1, 2, 1, and 3, 1. As you can see, all values of y here are the same, which is 1. But it doesn't matter. As long as your x, which are 0, 1, 2, and 3 are all unique, it is still a function. Let us now have another relation J with the x values 2, 4, 2, 5. At first glance, you'll see that there's a repetition of the x value, which is 2. But looking at it carefully, it was paired with the same value of y, which is 3. Therefore, it is only taken as 1, making it still a function. Let us now proceed to number 2, table of values. This is a table with x and y values. As you can see, all values of x here are unique and non-repeating. Therefore, this is still a function. We'll now consider another table of x and y values. Obviously, 1 was repeated thrice and is paired to different values of y, which are 1, 2, and 3. Therefore, this is not a function. Let us now consider number 3, mapping. This is a map of a relation with input x paired to output y. If we are having a problem identifying if this is a function, we will first make it into set of ordered pairs before we decide. We have here 10 paired to 15, 20 paired to 45, 30 paired to 25, and 40 paired to 35. As you can see, all values of x here are non-repeating, therefore this is a function. We have here another map of a relation G. Again, we'll transform this one into a set of ordered pairs. Therefore, we have A paired to X, B paired to Y, C paired to Y, and D paired to Z. The Y value, which is Y, was repeated twice, but again, it does not matter. As long as your X, which are A, B, C, and D, are all unique, it is still a function. We have here another map of relation H. Making it into a set of ordered pairs, we have 2 paired to 20, 2 paired to 40, 4 paired to 40, and 3 paired to 30. Notice that the x value, which is 2, was repeated twice under the ordered pair 220 and 240. Therefore, this is not a function. Let us now proceed to number 4, graph. Before we start with the items, let us first discuss the test which will help us in identifying the graph of a function. We have here vertical line test. It states that a graph represents a function if and only if each vertical line intersects the graph at most once. We have here the graph in number 1. We will be placing here vertical lines and we'll try to check if each vertical line will only intersect at one point. As you can see, each vertical line here intersects at 2 points of the graph. Therefore, this is not a function. Next is we have the graph in number 2. Let us first place vertical lines here. As you can see, each vertical line here intersects at only one point of the graph. Therefore, this is a function. We have here number 3. Placing vertical lines here will only intersect at one point. Therefore, this is a function. We are now on number 4. Placing vertical lines here will only intersect at one point. Therefore, this is still a function. We are now on our last item. It's a graph of a circle. Placing vertical lines here, you'll see that each vertical line intersects at 2 points. Therefore, this is not a function. That is all for today. Thank you and see you on our next video lesson. Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! For today, we will discuss how to get the domain of a function. The domain of a function is the complete set of all possible values of x or independent variable. So what are we waiting for? Let's start. In letter A, we have y is equals to 3x minus 2, and in letter B, we have 3x squared minus 4x. These are all polynomial functions. A polynomial function is a function having non-negative integer powers of x. So if we are given a polynomial function, then our domain is an element of real numbers. Let's proceed to letter C. X squared plus y squared is equals to 1. The first step here is to isolate y on one side, so we'll have to transpose negative x squared to the other side. So we have here y squared is equals to negative x squared plus 1. The next step is to place square root on both sides, so we'll have y is equals to the square root of quantity negative x squared plus 1. This is a radical function. To get the domain of a radical function, we have to take note of the value of the radicand, that is what's inside the radical sign. The radicand must be greater than or equal to 0, or else our answer will be imaginary. Substituting 1 or negative 1 in our x will give us a radicand of 0, while substituting 0 in our x will give us a radicand of 1. Therefore, our domain here is negative 1 and positive 1, including the numbers in between them. Or in symbol, we have x as an element of R, where negative 1 is less than or equal to x and x is less than or equal to 1. Number 4 is still a radical function. As you can see in our radicand, the x here should be equal or greater than 4 so that we can avoid negative numbers. Therefore, our domain here is x is an element of R where x is greater than or equal to 4. We are now on letter E. This is a rational function. A rational function is in fraction form where our numerator and denominator are polynomials. The domain of our rational function are all values of x except those values which will make our denominator 0. Remember, a fraction with a denominator of 0 is undefined. Let us now focus on our denominator. What value of x here will make our denominator 0? You're right, it's 1. Therefore, our domain here are all real numbers except 1. We are now on letter F. That symbol is a floor function of x plus 1. If you are given a floor function or a ceiling function, then your domain are all values of real numbers. To understand better the floor and ceiling function of x, let us consider the following examples. You will get integers as an answer for floor and ceiling functions. In floor functions, it makes you consider the nearest integer down. For example, we have here 1.3 goes down to 1, 4.9 however very close to 5 still goes down to 4, 7.6 goes down to 7, and 10.1 goes down to 10. While ceiling function make you think of the nearest integer up. For example, in number 1, 3.1, no matter how close it is to 3, it still goes up to 4, 1.8 goes up to 2, 8.4 goes up to 9, and 14.7 goes up to 15. That is all for today. Thank you and see you on our next video lesson. Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! For today, we will discuss functions in real life including piecewise function. Example 6. Give a function c that can represent the cost of buying X meals if one meal costs 40 pesos. The cost here is our y, since our payment will depend on the number of meals that we will buy. Now, if every meal is 40 pesos, we will simply multiply 40 to the number of meals that we will buy in order to get our cost. Therefore, our function here is c of x is equals to 40x. Let's now proceed to example 7. 100 meters of fencing is available to enclose a rectangular area next to a river. Give a function a that can represent the area that can be enclosed in terms of x. This is the figure of the rectangular area. As you can see, I have placed y on the other side because a rectangle has opposite sides that are equal. Now we have to fence these three sides with the available 100 meters of fencing materials. So we'll have here x plus 2y, because there are two y sides, is equals to 100. Now, as the problem stated, we have to get the value of the function in terms of x. Therefore, we have to isolate y on one side, transposing x to the other side, giving us 2y is equals to negative x plus 100. Now we have to divide both sides by 2 to get the value of y. So we have here 2y over 2 is equals to negative 1/2 x plus 100 over 2, giving us the final value of y, negative 0.5x plus 50. With this value of y, we can now solve for the function involving the area. Recall that the area of a rectangle is height times width. In our figure here, we used x and y for height and width, therefore our area is x times y. Now, since the problem stated that we only have in terms of x, we can retain x here and then y is equals to the previous answer that we got. So we have here a is equals to x and then y is equals to negative 0.5x plus 50. Multiplying x to each term, we'll have the final answer a is equals to negative 0.5x squared plus 50x. Let us now proceed to piecewise function. A piecewise function is a function composed of two or more functions over a different interval. Let us now proceed to example 8. A user is charged 300 pesos monthly for a particular mobile plan, which includes 100 free text messages. Messages in excess of 100 are charged 1 peso each. Represent the monthly cost for text messaging using the function T of m, where m is the number of messages sent in a month. Let us understand the problem sentence by sentence. Let's start with the first sentence. 300 pesos with 100 free text messages. So our first function here is T of m is equals to 300 for 100 messages and below. Now for our second sentence. In excess of 100, there is a charge of 1 peso each message. So our second function here is T of m is equals to 300 plus quantity m minus 100 if m is greater than 100. So for example, you used 95 or 90 or 85 text messages in a month, you'll only pay exactly 300 pesos. However, if you manage to text 105 messages, then you will pay 300 plus 105 minus 100 is 5. That will be 305 pesos in that particular month. We are now on example 9. A jeepney ride costs 8 pesos for the first 4 kilometers and each additional integer kilometer adds 1.50 to the fare. Use a piecewise function to represent the jeepney fare in terms of the distance in kilometer. Again, we have to understand the problem sentence by sentence. We'll start with the first sentence, 8 pesos for the first 4 kilometers. Therefore, our first function here is f of d is equals to 8 if the distance is 4 kilometers or less. In the second sentence, for every additional integer kilometer, it will charge us 1.50 additional fare. So our second function here is f of d is equals to 8 plus 1.5 quantity, the floor function of d minus 4 if d is greater than 4. We use floor function here because remember, a floor function makes you think of the nearest integer down. So for example, if we exceed 0.5 kilometer, the floor function of 0.5 is still 0. Meaning, we won't be charged 1.50 because the problem states here every additional kilometer. For example, our destination is 1, or 2.5 or 3.9 kilometers away from home, then we will pay exactly 8 pesos. However, if our destination is 7.8 kilometers away, we will be using the second function. So we have here 8 plus 1.5. The floor function of 7.8 is 7 minus 4. 7 minus 4 is equals to 3. Then 1.50 times 3 is equals to 4.50. Therefore, our final answer is 12.50. That is all for today. Thank you and see you on our next video lesson. Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! For today, we will discuss about evaluating functions. We will be using the functions here, but before that, make sure you know how to do GEMDAS. This is the order of operating terms: grouping symbol, exponent, multiplication, division, addition, and lastly, subtraction. With this, we are ready to begin. Let us start with example 1. Let the value of x be equal to 1.5. Evaluating functions is simply substituting a given value to the given functions. Let's start with getting f of x. X is now 1.5. So to get the value of that one, we have to copy 3 and then substitute x to 1.5 minus 2. Now, this is multiplication. So according to GEMDAS, we'll start with multiplication before subtraction. So we'll multiply 3 times 1.5. That will give us 4.5. And then minus 2. Just copy that. So it will give us a final answer of 2.5. Next, let's proceed to g of x. The same thing, g of 1.5 is equal to, simply copy and then substitute the value of x. So that's 3 times quantity 1.5 squared minus 4. Again, x is 1.5. After that, we'll start with the exponent before multiplication. So we have here 3, 1.5 raised to 2. That will give us 2.25. And then you multiply this portion, so that will give us 6. Now again, start with multiplication before subtraction from our GEMDAS order. So this will give us 6.75. Then copy minus 6. So performing that one, it will give us a final answer of 0.75. Now let's start with h of x. Again, that's h of 1.5. So you will simply copy and then substitute the value of x. Square root of quantity 1.5 plus 4. Adding that, we'll have 5.5. Using your calculator, that will give us 2.34. And that is our final answer. Let us now proceed to r of x. Again, that's r of 1.5 is equal to, copy everything and then replace x by 1.5. And then multiply first. So that will give us 3 plus 1, and then that is 0.5. Therefore, that will give us 4 over 0.5. Dividing that one, it will give us a final answer of 8. Next, we have t of 1.5 is equal to the floor function of 1.5 plus 1. The floor function makes you think of the nearest integer down. So 1.5 goes down to 1. And then copy plus 1. So that will give us a final answer of 2. Let us now proceed to example 2. Letter A is f of 2x plus 1. In this case, 2x plus 1 is our x. Now this will be what we will substitute to the function f. So rewriting that one, f of 2x plus 1 is equal to copy 3, and then x here will be substituted by the entire value here. So that's 2x plus 1, and then copy minus 2. Now let us distribute or multiply 3. So 3 times 2x is 6x, and then 3 times 1 is positive 3, copy minus 2. So that is 6x. 3 minus 2 is positive 1. Therefore, this is our final answer. Let us now proceed to letter B with the given g of 4x minus 3. Again, this entire thing here will be our x. So we will substitute this one to our function g. Let's copy first. And this is equal to copy 3. And then x is now substituted by 4x minus 3, quantity squared, and then copy minus 4 times, again that's 4x minus 3. Since we have here an exponent of 2, so that is 4 raised to 2 is 16, x raised to 2 is x squared, and then 4 times negative 3, that's negative 12, times 2, that's negative 24. Just add x. Negative 3 squared, that is positive 9. And then negative 4 times 4x, that's negative 16x. And then negative 4 times negative 3, that's positive 12. Next is to distribute 3 on all terms here. So 3 times 16x squared, that is 48x squared. 3 times negative 24x, so that is negative 72x. And then 3 times 9, that is positive 27. And then copy these two terms here. Now we have here x squared, and there's no other x squared in these terms. So we'll simply copy 48x squared. Negative 72x and negative 16x are like terms, so we can still add them up. So that's negative 88x. And then 27 plus 12, that is equal to 39. This is our final answer. We are now on example 3. So in here, we have a different given, f of a plus b, where our f of x here is equal to 4x squared minus 3x. Since this is f of x, it means a plus b is our entire x, and we will substitute this one as a value of our variable x. So we'll just rewrite. This is equal to copy 4, and then a plus b is the value of our x, squared that 1 minus copy 3, and then a plus b again. Now we have here an exponent of 2, so that's a raised to 2 is a squared, and then a times b times 2, that's 2ab. And then b raised to 2, that's positive b squared. Now distribute negative 3, so that's negative 3a and then negative 3b. Now let us multiply 4 on all terms here. So we have 4 times a squared is 4a squared. 4 times 2 is 8. Copy ab. And then that is positive 4b squared. And then we'll just have to rewrite 3a minus 3b. There's no more like terms, therefore this is our final answer. That is all for today. Thank you and see you on our next video lessons. Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! For today, we will discuss how to add and subtract functions. We have here the following functions to consider later on. So let us start with addition. Number 1. That can be written as f of x plus, that is, p of x. Now we have to look at our given and then substitute the following functions here. F of x is equal to x plus 3, and then p of x is equal to 2x minus 7. Now we have to look for like terms here, like terms of the same variable and exponent. So we have 1 here, so that's 1x plus 2x, a total of 3x. And then 3 minus 7, different sign, subtract, which is 4. Take the sign of the bigger number, so that's negative 4. This is our final answer. Let's now proceed to number 2. That can be written as v of x plus g of x. Now we have to look at our given here and substitute according to our function. So v of x is x squared plus 5x plus 4. And g of x is x squared plus 2x minus 8. Now we have to look for like terms here, terms with the same variable and exponent. So we have here the following. There is 1 here and 1 here, so a total of 2. Then just copy the common variable and the exponent. Next, 5x plus 2x, a total of 7x. Now we have here 4 and 8, so different signs. Now we have to subtract. Take the sign of the bigger number, so it's negative. This is our answer. We are now on number 3. We can write that one as f of x plus h of x. Now f of x is equal to x plus 3, and then h of x is equal to the fraction quantity x plus 7 all over quantity 2 minus x. Now let us make both functions a fraction. So to do that, let us place a denominator of 1 to the first function. Remember that that is a valid step since all terms divided by 1 is just equal to itself. Now our LCD here is 2 minus x. Remember that we have to divide our LCD to the denominator and then multiply the answer to our numerator. So let's start. 2 minus x divided by 1 is just itself. Multiply to the numerator, so we have quantity x plus 3 multiplied to quantity 2 minus x. And then we have here 2 minus x divided by itself, so it's 1. 1 multiplied to the numerator, so we'll just have x plus 7. Let us now do the FOIL method here. X times 2, that is 2x. X times negative x, that's negative x squared. 3 times 2, that's positive 6. 3 times negative x, that's negative 3x. And then we'll just copy plus x plus 7, still over 2 minus x. Now let us look for like terms here. Negative x squared is just alone. There's no other x squared in these terms. So we have to proceed. 2x minus 3x, that's negative 1x plus 1x. So that will give us 0. We won't be writing that one anymore. So let's proceed to 6 plus 7. That is equal to positive 13. And then copy our denominator, 2 minus x, and this is our final answer. We are now with the next operation, subtraction. Let's start with number 1. That can be written as p of x minus f of x. Again, let's look at the given and then substitute. P of x is 2x minus 7 minus, enclose the second function in a parenthesis, x plus 3. Now we have to enclose it in a parenthesis so that we can distribute negative. We have here 2x minus 7, negative times positive, so that's negative x. Same with negative 3. We have here like terms, 2x and negative 1x. So that is 1x or simply x. Now we have the same sign here, so add and then copy the sign. And this is our final answer. Let us now proceed to number 2. So that can be written as v of x minus p of x. V of x is equal to x squared plus 5x plus 4. And then copy minus, always enclose the second function in a parenthesis. So we have 2x minus 7. Again, that is because we have to distribute negative to each term later on. So let us copy this portion here. And then negative times positive, so that's negative 2x, negative times negative, that's positive. Now let's look for like terms here. There's no other x squared, so we'll simply copy this. And then 5x minus 2x, so that is 5 minus 2, so positive 3x. Now 4 plus 7, that is positive 11. And this is our final answer. We now have number 3. That can be written as h of x minus p of x. Now looking at our given, h of x is equal to the fraction x plus 7 all over 2 minus x. Minus, our p of x is 2x minus 7. The second function should always be enclosed in a parenthesis so that we can distribute negative later on. And we will make it into a fraction, so it's all over 1. We have to make it into a fraction because the first function is a fraction. Our LCD here is 2 minus x. Remember that you have to divide the LCD to the denominator and multiply the answer to the numerator. So we have here 2 minus x divided by 2 minus x, it's 1. 1 times x plus 7 is x plus 7. Then copy minus. And then we'll proceed here. 2 minus x divided by 1 is 2 minus x multiplied to the numerator. So we have here 2x minus 7 multiplied to the LCD 2 minus x. We will first perform the FOIL here. So copy x plus 7 and then 2x times 2 here is 4x. 2x times negative x, that's negative 2x squared. And then negative 7 times 2, that's negative 14. Negative 7 times negative x is positive 7x. And then simply copy our LCD 2 minus x. So we will distribute the negative now. So copy first x plus 7. So that will be negative 4x. Negative times negative is positive. 2x squared. Negative times negative is positive 14. Negative times positive is negative 7x. Again, copy our LCD. Inspecting our terms here, we only have 1 with variable x squared. So we'll simply copy that 1. And then we have here x, negative 4x, and then negative 7x. So that is a total of negative 10x. And we have 7 plus 14, that is positive 21. And then we will simply copy the LCD, 2 minus x. And this is our final answer. That is all for today. Thank you and see you on our next video lesson. Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! Hello everyone! We are now on multiplying and dividing functions. Let us start with multiplication. Number 1. So we can write that one as f of x multiplied to p of x. Again, looking at our given here, we will only substitute f of x is equal to x plus 3, p of x is equal to 2x minus 7. Now we will do the FOIL method. X times 2x, that's 2x squared. X times negative 7, that's negative 7x. 3 times 2x, that's 6x. And 3 times negative 7 is negative 21. Now we will simplify like terms here. We have negative 7x plus 6x. Difference sign subtract, so that's negative 1x. Now we don't have to write the constant 1. And then copy negative 21, and this is our final answer. Let us now proceed to number 2. So we can write this one as p of x multiplied to v of x. Now p of x is equal to 2x minus 7, and then v of x is equal to x squared plus 5x plus 4. Now we will do here multiplication by term. So we'll start with 2x. So 2x times x squared, that's 2x cubed. So there are 3 x's here, 2 from here and 1 from here. And then 2x times 5x, that's positive 10x squared. And then we have 2x times 4, that's positive 8x. Now we will distribute negative 7 this time to all terms. So that's negative 7x squared. Negative 7 times 5x, that's negative 35x. Negative 7 times 4, that is negative 28. Now let us look for like terms. X cubed here is the only x cubed in this term, so we'll just copy. And then we have here x squared and x squared. So we have 10 minus 7. So that is positive 3. Copy the common variable and exponent, x squared. Now 8x minus 35x. That is equal to negative 27x. And we have here to copy negative 28, and this is our final answer. Let's now go to number 3. We can write that one as f of x multiplied to t of x. Now f of x is equal to x plus 3, and then t of x is equal to the fraction x plus 2 all over x plus 3. Now, in multiplying fractions, we have to make sure that all of our given are in fraction form. So, x plus 3 has a denominator of 1. Now, remember that in multiplying fractions, we have to multiply numerator times numerator all over denominator times denominator. So, we have here quantity x plus 3 multiplied to quantity x plus 2. And then 1 times x plus 3 is just x plus 3. Now we have here the same binomial. Therefore, we can cancel them both because they are just equal to 1. 1 times x plus 2 is just x plus 2. And this is our final answer. We are now ready to divide functions. So we have here v of x all over g of x. Again, v of x is equal to x squared plus 5x plus 4 all over our g of x here is x squared plus 2x minus 8. Now we will factor this out so that we can see if there is a common factor here. So x squared is from multiplying x times x. And then 4 here, we have to look for factors. Let's list it down. Positive 4 times 1. Or it could also be negative 4 times negative 1. We also have positive 2 times positive 2. And negative 2 multiplied to negative 2. Now we have to add each of these factors here. And our goal is to get the middle term, which is 5. So 4 plus 1 is 5, negative 4 plus negative 1 is negative 5, 2 plus 2 is 4, negative 2 plus negative 2 is negative 4. So among the pairs here, we have 4 and 1, which is equal to 5 when you add them up. So our factors are x plus 4 and x plus 1. Let us also factor our denominator. So x squared is from multiplying x times x. And negative 8 here, we have several factors. That's negative 8 times positive 1. We also have positive 8 multiplied to negative 1. And we also have negative 4 times positive 2 or positive 4 times negative 2. This time we will add up all of the factors. Our goal is to get positive 2. Which is the middle term of our denominator. So we have here, negative 8 plus 1 is negative 7. 8 plus negative 1 is positive 7. Negative 4 plus 2 is negative 2. And 4 plus negative 2 is positive 2. And these are the factors that we need. So we have here x plus 4 and then x minus 2. As you can see here, we have a common factor. And we can cancel them both because they are just equal to 1. So our final answer is x plus 1 all over x minus 2. You might wonder why we did not cancel out x here. That is because x is only a part of a whole. If we wish to cancel x, we have to include 1 here because they are taken as a group. And since there's no x plus 1 in our denominator, or there is no x minus 2 in our numerator, then this is our final answer. We are now on number 2. So we can write this one as t of x all over h of x. Now t of x is a fraction. We have here x plus 2 all over x plus 3. And then we will divide this one to another fraction, x plus 7 all over 2 minus x. Now the rule of fraction states that we can make this division into multiplication and then we will just reciprocate the second fraction. So we'll copy the first function here, multiplied to the reciprocal. We have 2 minus x all over x plus 7. Now the rule of multiplication is just multiplying numerator to numerator. So that's x plus 2 multiplied to quantity 2 minus x, and also multiply denominator to denominator. So we have x plus 3 and then multiplied to x plus 7. Now there is no common factor here, so we'll just do the FOIL method. X times 2 is 2x. X times negative x is negative x squared. 2 times 2 is positive 4. 2 times negative x is negative 2x. In the denominator, we have x times x is x squared. X times 7 is positive 7x. 3 times x is 3x, and 7 times 3 is positive 21. Now let us look for like terms here. We have negative x squared. We also have here 2x and negative 2x, that's equivalent to 0. So we are left with plus 4. And then below we have here another like terms. So we'll write first x squared and then 7x plus 3x, a total of 10x, and then we'll just copy here plus 21, and this is our final answer. That is all for today. Thank you and see you on our next video lesson. Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! Hello everyone! Our topic for today is all about composition of functions. Composition of functions is applying one function to the results of another. To better understand this one, let us proceed to the examples. Let's start with number 1. Our little circle here is the symbol for composition of functions, and we can write this one as g of f of x. It means to say we will be using the function g, but our x here will be replaced by the entire function f. So to visualize that, this function here will be our value of x. So that would be the square root of our x is 2x plus 1, and then we will just copy plus 1. That will give us a square root of 2x plus 1 plus 1 is 2, and this will be our final answer. Now let's have number 2. So that is q of f of x. So the same thing, we'll be using function q, and that is this one, x squared minus 2x plus 2. But our x will be the entire function f, so this one will be our x value, and there's also another x here. So that will give us quantity 2x plus 1 raised to 2 minus 2 times, that's 2x plus 1 again, and then we'll just copy plus 2. This can be written as 2x plus 1 multiplied to itself, and then we'll just distribute 2 here, so that is negative 4x, negative 2 times positive 1, that's negative 2, and we'll just copy plus 2. Doing the FOIL method, we have here 4x squared, 2x times 1, that's positive 2x, 1 times 2x, that's positive 2x, and 1 times 1 is equal to positive 1. We'll copy negative 4x here, and this is 0, so we don't have to write anything. Now let's combine like terms. There's only one x squared here, so we'll just copy 4x squared. And we have here 2x plus 2x, that is 4x, minus 4x, that's equal to 0, so we're only left with plus 1. So this is our final answer. We have here number 3, that is f of p of x. So we will be using function f here, but our x will be the value of our p of x. So again, to visualize that one, p of x will be the new value of x in our function f. So to write that, we have here 2 times our p of x here is 2x plus 1 all over x minus 1. And there's still plus 1 from our function f. Since p of x is a fraction, we'll have to make 2 b over 1, and we will multiply numerator to numerator and then denominator to denominator. So we have here 2 times 2x is 4x, 2 times 1 is positive 2, all over 1 times x minus 1 is just x minus 1, and then copy plus 1. Since this is addition of fraction, our LCD is x minus 1. Remember, our LCD here shall be divided to our denominator, and the answer shall be multiplied to our numerator. So let's start. X minus 1 divided by x minus 1 is 1. 1 times our numerator, so we'll just write here 4x plus 2. Then 1 has a denominator of 1. So we have here x minus 1 divided by 1 is itself. So that's x minus 1 times 1. So we'll just write x minus 1. And now we will look for like terms. 4x plus 1x, a total of 5x. 2 minus 1, that's positive 1. And then just copy our denominator, x minus 1. We are now on our last item, capital F of p of x. So we will be using here the function of capital F, but our x will be replaced by the entire p of x. So this one will be the value of our x. So we have here the floor function of 2x plus 1 all over x minus 1, and then copy plus 1. Now what if we have this given? As you can see here, our x is now replaced with 5. So we'll simply substitute 5 here. So that's 2 times 5 plus 1 all over 5 minus 1. And then we'll copy plus 1. So that will give us a floor function of 10 plus 1, that's 11 all over 4. And then copy plus 1. 11 over 4 is 2.75. Now a floor function makes you think of the nearest integer down. So that would be, we have 2.75 goes down to 2, and then copy plus 1. So our final answer here is 3. That is all for today. Thank you and see you on our next video lesson.